Okay. Uh, Dear faculties and research scholars, I welcome you for the session 4 of this 6 days online ATAL FDP. Uh, this session will be handled by I'm handled by myself Manibharathi D, who is acting as a co-coordinator for this ATAL workshop. We'll start the session. Yes, good evening all. Myself, Manibharathi, working as assistant professor in the Department of ECE, Government College of Engineering, Salem. In the session 4, I'm here to discuss about the platform and tools for AI and ML. I know it's very difficult, right? And the time of 7:45, I mean, starting a new session is challenging. I want to keep it as much as engaging as possible. Hopefully, I can deliver. So, uh, we'll start with the introduction to machine learning. See, machine learning, if someone is saying about AI and ML, right? What is AI? Artificial intelligence as a AI, right? Where we have the machines which perform the task which normally requires the human like intelligence, right? Examples I can give, like you want to recognize a face, understand a language, you want to solve a problem, and something like decision making. These are all need human intelligence, right? If a machine can do such thing, then um, that's your artificial intelligence. Okay, that's your artificial intelligence, right? Then what about the machine learning? If you take the artificial intelligence bigger picture, inside that the subset is your machine learning, right? In machine learning, we have the patterns, right? The data we call a pattern of data, right? Like the shopping we do. Okay, from that, your Amazon is saying what would be your next purchase, and how a doctor is working. If say asking me a doctor, he is taking a medical X-ray. You want to classify whether the patient is a normal one or is have a broken bone. So it's a pattern, right? So the machine learning or ML is a subset of AI. Okay. The thing about this is we need not to go by step instruction. Instead of programming step by step instruction, we give the machine the data, and the machine learns from the patterns in it. Okay, we did not go do the programming, right? We give the data and the machine learns from it, right? For example, you are feeding thousands of X-ray images, and we are classifying it as like a normal one or a broken bone, right? That means the machine is learning from the pattern among which X-ray is a broken and which X-ray is a normal X-ray, right? Next, if you feed a new one, the unknown X-ray, it will be able to identify with surprising accuracy whether it is a broken bone or a normal one. So that's the machine learning. The machine is learning by itself, right? That's the thing. And why it is so important, right? We know that in today's world, everything is data driven. Okay, you take any healthcare to identify a disease, this AI will be helping. You take a transportation, your AI or machine learning is helping to say the traffic prediction. You can see in your Google map the traffic prediction, right? Based on the previous passengers or the what I can say the persons who are using the route, based on the time taken to pass that area, it will identify whether it is heavily traffic or a non-traffic zone, and it gives route optimization. And take a finance, it is helps to prevent the frauds and manage risk. You take the agriculture, it I can say like predicting the crop yield and weather prediction. I take the education, right? Coming to our education, AI personalizes the learning experience for each student, right? Maybe for each student may be different in their learning. So if a teacher or a professor will have the same method of teaching for the entire one, right? Entire class. So if you go for a AI, it will personalize based on the student level of knowledge or under its level of grasping. It will be helping to. It will be what I can say. It will personalize his learning experience. These are all the impact your AI or ML is going to have. Yeah, the session is about the platform and tools. Why this platform and tool? We know that this AI and ML has its own challenges, right? Because it requires the coding skills. Okay, there should be a coding skill is required, and the data sets is very large, and it needs a huge computing power. These are all the challenges we have. So, if you want to do these things from the scratch, if you're using your normal laptop, the process would be very slow and it can be frustrating sometimes, and sometimes it's not possible even to execute. So, what we do, we get the help from the platforms and tools. The platforms and tools are like just a shortcuts, I can say helpers, right? They provide ready to use environment. They provide ready to use environment. So we need not to waste time in installing those softwares. And it also comes with preloaded libraries and sample data sets. So we can experiment. And the important thing is it is free or of some, it's most of the time it is low of cost resources. So it is very great for the students, researchers, professors, and teachers who don't always have access to high-end resources. So these are the advantages why we choose instead of doing coding and using the high computational data and using high computational power, we go for the platform and tools to derive these benefits. Then why specifically we are interested in Python for your AI and ML? The first thing, it's very readable, right? We say the high level languages are readable and beginner friendly syntax. The syntax is very simple and readable, right? It's almost like plain English. So it's very beginner friendly. Then it has a huge ecosystem of libraries like NumPy, Pandas, Scikit-learn, TensorFlow, PyTorch. This NumPy we use for numerical computing. The Pandas we use for handling data. Scikit-learn we go for the machine learning and deep learning. And deep learning we go for this TensorFlow and PyTorch. And this Python, right? It runs on the browser. We know not to install anything, right? You take the example for like Colab, Google Colab, or Kaggle. No need to install anything, right? It runs on the browser. You don't need to install the heavy software. Just we require is the internet connection. That's enough. So it becomes independent of the machine. Then we have a very active community. Okay, millions of people already working, so they are contributing their own resources in this field, and the abundant examples they have created. And we have this notebooks. You take the Jupyter notebook we are using in Colab or Kaggle, where we can code, we can have the text, we can have the charts, everything in a single place, right? That's the called notebook. That's all the advantage of using Python in for AI and ML. I want to quote this example. In the year 2020 during pandemic, IIT Hyderabad used Python and TensorFlow to build the machine learning models just but to analyze the chest x-rays for COVID detection, right? They didn't build the code from the scratch. They used the libraries and they started working. So yeah, this shows that the Python is a bridge between the idea and the implementation. And what are the tools we have? They say the platforms and tools. We start with the tools. start with the tools. We have the programming and libraries. These are the core building blocks. For example, the NumPy, Pandas, Scikit-learn, TensorFlow, PyTorch. They allow us to write the code, process the data, and build models. And the data platforms, AI uses data platforms like Kaggle, UCIML, the Kaggle repository, Hugging Face, which gives the ready to use data sets. Because the data set is ready, which saves us a lot of time, and we will get the quality of data for our experiments. Then what about the clouding platforms? You are running your machine, you are running your YAML, right? If it's running on your computer, it needs heavy computing power. As I said earlier, your Google Colab, Kaggle kernels, AWS SageMaker, these are all help us to run a very big model without the need of any supercomputer at home. Then we have at last this AutoML tools, right? It's like the AI that builds AI. They automate the process, right? Using AI, we will be building our own AI, right? The coding AI will be writing its own AI codes, like Google AutoML, H2O AI, Data Robot, Rapid Miners. These are all few examples I can give. Then what about the visualization and workflow tools? Now, once the results are ready, right, we want to present it so that everyone can easily understand. This Power BI, Orange are all visualization tools. And Python has its own libraries like Matplotlib and Seaborn can be used as a visualization tool. I want to give this example like, the Swiggy and Zomato, right? How they are working. They use the full stack of tools, like they use the data platforms to store the customer data, cloud platforms to run the recommendation model, ML libraries to predict what food you may like, and visualization tools to monitor real-time deliver performance. So these tools are come together. Okay, but that's the big advantage of going for Python. Now we start with the NumPy. The NumPy is a numbers and array, right? Why we go for NumPy? See, it's a core of numeric computing. Okay, it powers other libraries. We can do linear algebra, matrix multiplication, random number generation, reshaping, vector operation. This operation can be done in few lines of code. It is very much faster than using normal Python list. And we'll be seeing these examples, right? I will be sharing in Colab, you're running these few examples. We'll go through the slides, and after this, we will be going through Colab, and I'll be running few of the codes. Then Pandas it's all about working with tables of data, right? If you have a spreadsheet like table, right? So your Pandas will be helping to work with that, right? It helps in like cleaning, filtering, grouping, exploring the data, filtering, aggregating, merging. Those are all done by these Pandas. Then is Matplotlib and Seaborn. This Matplotlib is a visualization tool, right? It's of low level and it gives flexible plotting. It is like the foundation of plotting in Python, right? It gives almost any kind of graph like line graph, scatter graph, bar plot, histogram, pie chart, everything. And what about the Seaborn? Seaborn is like an the what I can say, it's a statistical plot with it is built on matplotlib, right? It's like a bit advanced. It gives a beautiful statistical plots, okay, like heat maps, box plots, pair plots, those things. Then why this scikit-learn, right? Regarding the plot, I want to say this example, right? If you're watching cricket, right? You know these platforms like ESPN Cricket for CrickBus, they use a lot of visualization tools. Like you can see the run rate graph is there, the wagon wheel chart is there, the showing the batsman pattern, and the heat map where the bowlers are pitching their balls in the line and length. These are all done. These are all the examples of matplotlib and seaborn charts. These gives additional insights about the data. And remember that without visualization, without this plot, the data is simply blind. It's only a number, right? With only a number, it doesn't derive, I mean, does not give a complete picture, right? Once the data is compared or plotted, once you're able to visualize, then it gives the good information. So with visualization, the data will be able to speak. Okay, data speaks with visualization. And this scikit-learn, right? This scikit-learn is like this is everything in machine learning. Okay, is done can be done using this library, scikit-learn. It's an important library. And why it is popular? You can say that it has a consistent workflow, right? Like you see, the workflow is like any model you take, it will fit X with Y, right? So what is X? If you see here, X is the input of the features. Okay, X is the input of the features, right? To in the last session, Professor G was discussing that something called black box, right? So we have a system where the machine is going to learn from the data. So we will feed the inputs and we'll give the corresponding label or the targets. Like I give the example like a X-ray, a normal bone and a broken bone. And for each of the X-ray, it will be identified as a normal bone, broken bone. They are the labels. Normal or broken bone are the labels. The input is the X-ray, right? So if I give this pair, the input and output, the machine will learn from it. Okay, that's called fit. That's learn from the label data, right? Then after learning, what is the next step? We will feeding the new input. That is the X new. Okay. So the learned model, which we created using fit X comma Y, is used to predict for the new input X new to make the prediction, right? Okay, now we are making the prediction. The prediction may be right or may be wrong, right? In this case, we have to compute the score, right? Further, what we do, we'll find out the X test input, we'll find out the Y test output, we'll build a metric like accuracy for classifiers, those things. Then another thing, this scikit-learn is a model zoo where we can try very quickly. Like in your machine learning, you'll be familiar things like linear or logistic regression, okay, which is simple, fast, and interpretable baselines, support vector machine, or tree random forest gradient boosting, k-means, principal component analysis. These are all ready-made codes are available. Ready-to-use algorithms are available for this. That's called they are saying it's a model zoo. And it also has helpful utilities. Helpful utilities, right? What is a utility? Like we can train, test, split. Train, test, split, right? Okay. So which makes the what I can say for training, it itself like I can say 80% of the data is used for training. When the system is ready and it's trained, then remaining 20% of the data can be used for test. Then we can do for cross validation. Very important. See, it helps to evaluate the robustness, right? Via multiple splits. if the data set is highly imbalanced, right? Like I can say, what is the probability of saying a person having 6 fingers in a hand, right? And that person having a 6 finger, and I can say the output is like give a, like what I can say, rough analogy. They're having 6 fingers, and we are having some attribute, right? They are very tall, 6 feet high. Okay, the person having 6 fingers, 6 feet tall, right? So if you take the person having 6 finger, it's highly imbalanced. Okay, that is highly imbalanced because if you take thousands and thousands of people, only few will be having 6 fingers. And among those persons having 6 finger, the persons who are all 6 feet tall is very minimum. It's nearly, I can say, is very low. Okay. So if you are going by like trained split data, like 80% for testing and 20% 80% for training, 20% for testing, it's not that much. It won't work in a proper way, right? So what I can do is I can go for cross validation. I have to split the data, the raw data, into multiple splits. These all can be done using scikit-learn library, and we have pipelines. And see, for all this, we have the codes which will be running in your collab. We'll be seeing those things. Okay. So pipelines, it's a chain pre-processing plus the model. And the metrics, the accuracy, F1 score, ROC, AUC, regression errors, and some random search like tune hyperparameter systematically. These are all can be done using scikit-learn library. So the 4 steps, the scikit-learn library will always follow these 4 steps, right? And I want to quote this example, right? If you take the banking, okay, right? They Banking uses machine learning models to detect fraudulent transactions. How? It will see the past transaction of data. Then anything unusual is happening, like a large transfer of money to a new location. Then quick transfer, intermittent, like what I can say. Quick, very short span of time, many transfer is happening. Then it raises the concern, right? By this method, it helps to protect the customer. So this scikit-learn makes the machine learning practical, fast, and safe, and is just a go-to library for the student, researchers, and professionals who are starting their machine learning journey. That's a big thing about this scikit-learn. So what is the workflow, right? And you take the workflow, the step 1, as we discussed, we will be splitting the data into train and test split. Okay. And we know that the test part is unseen, right? Because that is we are going to test unknown. The unknown input, we are going to identify what is output for that input. Okay. That is split. Then it does the cross validation for robust system, we have to do cross validation. Then it does the pre-processing. In many cases, this pre-processing is very important, like some data may be missing. We have to scale the numeric features, right? Okay. Like I can say, if you take the student academic mark, some universities provide the percentage scale, some university provide in CGPA scale, right? Someone scoring 9 CGPA is much better than some students scoring 60 percentage, right? So their different scaling is there, right? Okay. So in that case, we have to normalize. These are all done in the pre-processing stage. And we have to encode the features. Again, the system can understand only numbers, right? Okay. Like if you say any feature, we have to represent in number. That's called encoding. Then we have to choose the suitable model, either it is logistic regression, SPM, trees, or K-means, or PCA. Then we will fit the model, we'll predict it, we'll check the score. At last, we evaluate the metrics like accuracy, F1 score, ROC. Then we will go for the confusion matrix. Okay, so this is another example we'll be discussing in your Google Colab. Just you can quickly go through it. Like, see, we have iris. Iris is a flower, right? We have a data set. And there are three species of iris flower is there. One is the Setosa versicolor and Virginia, Virginica, Virginica, right? And what about the feature of that flower is the like again sepal length, sepal width, petal length, and petal width. So we have the four features, right? Give me a second. Okay, right. The first step we will be loading the data, right? The next one, uh, this iris data set actually has 150 iris flowers, right? For each flower has their own these four features. One second. Okay. Okay. Well, these four features like sepal length, sepal width, petal length, and petal width, right? 150 iris flowers are there, and this 150 will be one among the three iris flowers, three species: Setosa, versicolor, and Virginica, right? Now, now the data is loaded. When the data is loaded, next we will be splitting the data. We will be splitting the data into training set and testing set. In the training set, we'll be using 80% of the images. That is from the iris data set images. We'll be using 80% to train the system. So system, how it is trained? Because it knows the flower as input and the output is also known, right? What type of species it is, whether it is Setosa, versicolor, Virginica. So 80% of the images out of the 150 are used to train. Remaining 20% is unknown. We'll be using only for testing purpose, right? So after splitting the data, we will be ensuring um, we train the model on one part and we'll be evaluating on the unseen data. This unseen data is the 20% test set. And we'll be using for stratified split. Okay. Normally, we don't go for always a single 80% split and 20. We will go for many splits. Like every time, the random 80% is chosen, right? So that such that this class distribution becomes very balanced. Think about the case. You have iris flower, right? 150 iris flowers are there. This setosa is only two setosa flowers are there. Remaining 148 flowers are in these two categories, versicolor and virginica, right? So there is every chance that these two flowers in setosa will be coming under the training data set itself. Okay, so that becomes a highly unbalanced. So in that case, we go for the stratified split. Then next we go for the pipeline creation. This pipeline which ensures a smooth flow where we will have the standard scalar which standardizes a feature like mean is 0, variance is 1. We go for logistic regression because it's used for multi-class prediction, right? As we know, the three flowers is a multi-class. Three, it means two class is binary, more than two is multi-class classification. Okay, then we go for the last one is the model evaluation, right? Model evaluation. During evaluation stage, we perform 5-fold cross validation on the training set. Each fold we train on 4 parts and validate the one part. Here, the output is the mean, accuracy, and standard deviation. And the 5th step is the model training. When the fit pipeline model is ready, the entire training set is fit on the fit pipeline model. Then model learns the parameters using standardized data. Okay, from the 80% of the data, the model gets trained. So the model is learning from the data. We are not giving the explicit program to learn. You see, in the earlier days, before machine learning, we have to say something like this color, this pattern, this length, those things. Nowadays, you need not to give the right explicit programming. From the data itself, from the picture itself, from the image of the flower itself, the model will learn itself. Right? That's the machine is learning itself. That's why it's machine learning. So we go for testing and reporting. That's the sixth stage. So it predicts the test set. Test set. Here we use the classification report, which provides the precision recall F1 score for each class. Okay. And then another example we are going to see is the a Titanic data set exploration, right? Data set exploration. You know the Titanic. Okay, the Titanic. The Titanic. What I say, the ship, the passenger ship, right? Which unfortunately during this maiden voyage got drowned, right? It has like 891 passengers data is there. Okay, 891 passengers data is already there. Okay, nearly around the 2000 passengers travel, right? 81, 91 passengers are there, and each passenger has 12 columns. These 12 columns are the features. What about the feature of each passenger? It can be like age of the passenger, sex, whether they are male or female. What about the fare they pay? Whether they survived the, I mean, what I can say, they survived the accident. Those things. Okay, and I see your Python or your I mean the tool is helping to learn those things. Like we can preview the data, like showing the first five rows. Then it helps to show the data set shape. Okay, what is the shape of the data set? It is a matrix. How many rows? 891 rows. How many columns? 12 columns. So 891 rows, 12 columns. And also if you give df.info, this gives the what are the data types available, right? If suppose a passenger name is missing, it gives a not a number, and the cabin has many missing, and you will see the data sets, right? I will show you data sets there. You can understand these things very easily. Again, I will be refreshing those things there when we're discussing that point, right? We're discussing the collab, we'll be going through these things again. Then it gives the summary statistics. If I say what is described, it gives the count, mean, standard deviation, what is the minimal, what is the quartile, what is the maximum value. And also gives some insights like what is the average age, what is the fare distribution. Okay, you will see it is highly skewed. Like only few passengers paid very high amount. And what about the target variable? The target variable is the survival, right? The passenger survived or not. In this data set, we have 891 passengers who traveled in a Titanic ship. Among them, if they have survived, the label is 1. If unfortunately if they lost their life, it's a non-survivor, the label is 0. And this shows that the data set is highly imbalanced. The reason is very simple. The death is more than the survival. It is skewed. And some insights we can derive, it shows that among the 891 passengers who traveled the Titanic ship, the average age is 29.7. The very young people, average age. And the median is 28. And what I can say, some missings, some passenger age is not known, and some passenger ticket fare may be not known. So among those entries, 177 entries are not available. Among the age, 177 passengers, data age is missing, right? Among the fare, it is 14.4. I think it's in dollars, right? The maximum fare, okay, maybe the rich one, affordable one, they would have paid for the luxury charge of $512. And it also helped to do the group analysis by group by the sex, and we can say how they survived or not. And this gives the information like women had much higher survival rate than men. The reason would be known that we watch the movie. Its reason is very clear. The first preference they are given to the kids and the ladies, right? Yeah, that's what the women and children first. That's the rule they follow during evacuation. That would be the right. That would be the reason for the women having higher success, mean survival rate than men from the Titanic disaster. Then we will see about what are the data platforms, right? This is a quote I want to share here. The data is the new oil, right? Now the entire world is driven by the data, right? So ML needs the quality data sets. So these data platforms like Kaggle, UCI, ML repository, Hugging Face data sets all gives these ready-made data. Okay, because this data acts as a fuel for your AI and ML. Without any quality data, you see your machine learning model will not work. Okay, that's very important, right? If you want to understand our handwriting recognition, I have to feed so many handwritten text and I have to classify and it should be trained what is the letter written, what is the correct letter. I mean, what is the correct letter? In that way, it has been to be trained. It's not for, you see, if you take an individual person, their own way they are writing the characters. Think about the entire population. So those many data are required. So these data are fortunately available in the platforms like Kaggle. It is one of the most famous platform, ML community platform. It provides thousands of data sets and coding notebooks are there, and it is routinely keeps. It routinely holds competitions for the researchers. The student, researchers, and professional use Kaggle. I mean, not only for just data, but also to learn and share the solution. This UCI ML repository, it's another platform used by the students. It contains smaller, clean data sets that are great for teaching and benchmarking algorithms. These Hugging Face data sets, it is used to provide for NLP, computer vision, audio, and it is a go-to place for transformers and generative AI. Right, see, Kaggle, in Kaggle, there is like Kaggle hosted a COVID 2019 data challenge, right? Where it encouraged many Indian teams to contribute insights about the case prediction and spreading patterns. Okay. So what happens? People are contributing in the Kaggle data set. Any researcher can get those data and I mean they develop their own model. They can test it. They can work on that, right? And even in India, many startups in healthcare and agriculture, they are relying on these open data set from these platforms to prototype solutions quickly because they don't have time to visit the farm, collect the data, develop their models. The ready-made model is available. Only job they have is the uh, to develop the model, not to worry about the data. Okay. So the point here I want to stress here is the data platform saves the time, it promotes the learning and makes high quality data accessible to everyone. That is the big thing about the data platform. Then we have something called cloud platforms. See here, see why cloud platform? Because nowadays we never need a powerful computer with us, right? Because your machine learning algorithm can run anywhere, anytime. It runs on the browser. Only thing, internet connection should be enough. That's enough. And as I said earlier, the CPU, GPU, TPU are all free or low cost access. These are all done in the cloud. And the popular cloud platforms are this Google Colab. This offers the free Jupyter notebooks and GPU, TPU also it's offered there. Maybe some limited amount of time they are permitting to use it. And this Kaggle kernels, that's also a popular platform in operating in cloud. Then industrial tools like AWS SageMaker, Azure ML. Then we have AutoML tools. In AutoML tools, it's quite interesting. That's AI builds AI, right? That's what instead of manually trying different algorithms and feature engineering steps, hyperparameter tuning, this AutoML does the job on its own. Right? Okay, that's it automates the model training and tuning. So what does it achieve? It saves the time, very minimal coding is required, and even a non-computer science professionals are able to use the machine learning. And popular AutoML tools are this Google AutoML. It's a part of the Google Cloud designed for building ML models with just a few clicks. H2O.ai is an open source, widely used in enterprises, and it's used in predictive modeling. Then we have data robot, and it's a commercial tool that automates model training and deployment. And we have rapid miner, which is a visual drag and drop environment, and it is popular in academic setup and industrial setup, industrial training. And visualization tools, unless you visualize it, the data is very difficult to understand, right? If you see the data in form of a graph or a chart, it is very easy, right? So visualization is very important. And another thing about visualization is we can spot the patterns, right? In which data is away and which data can be grouped. Those patterns, trends, and outliers, like which data are, like, can say, which are far away from the grouping outliers. Those can be seen only by visualization instead of seeing the raw data numbers. This visualization helps in achieving those things. And popular tools like Power BI, Orange, um, and this Matplotlib, these are all the popular tools in visualization. And typical use cases like correlation heat maps, histogram box plots, interactive dashboards for decision making, and visual ML pipelines for beginners. And if you ask the trends and opportunity, it's no code or low code AI, right? See, no code AI, right? We don't need to code. Just you have auto ML is there, drag and drop platform is there, generative AI, this chat GPT we know is a generative AI, DALI, Copilot, where you can write to the Copilot that writes its own code, Edge AI, that's a Edge AI runs on the mobile IoT devices, explainable AI, where which makes ML decisions transparent, and AI for social good like healthcare, climate, and education. These are the trends. If I asked about the opportunities, this research and innovation, interdisciplinary applications like healthcare, finance, engineering, agriculture, startup and industry demand is there, and skill development, future careers, those are the opportunities available. Now we will shift into the collab and we will run the codes. I will explain them like a hands-on session. I hope the screen is visible. Yeah, you see, this is Colab, right? Google Colab. Just you can see here. You can just search Google Colab and sign in. That's it. Okay. Here everything will be running things in online. You just need internet connection, and the coding will be saved in your Google Drive. You can see it is Google is saved in the Google Drive. I have named this file as ATAL FDP.ipynb. Okay, and we can see this is the notebook. I can say this is the notebook, and I can show you the. See here, I can insert the code. You can see if I press the code, I can type the start writing code. You can see you can start. You can generate the codes. AI is helping, and you can insert a text also. Okay, those are things available. And to start with, I have just written the code and I have pasted it, right? So you can see the first thing I'm going to check what is the version used in this collab. So what I'm saying is import sys, numpy, pandas. I'm going to import all the libraries and I'm going to print what is the system version, what is the print version of the numpy, pandas, scikit-learn, matplotlib, those things. So just you type the code, you run it. It takes a few seconds. Give me a second. Yeah, you can see here the version is June 4, 2025. And the version of the system is 3.12.11, and the version of this numpy is 2.0.2. The version of pandas is 2.2.2 is given, right? Okay. Next, using numpy, we are going to work out a few things like array creation, right? As I explained earlier, uh, what about the array creation, right? What I'm going to say is we are going to import numpy and I'm going to call it in short form as np. You can give any name. Okay, so I am giving an array. These are the comment line. The hash symbol, the green color are the comment lines. For easy understanding purpose, I have used the liberal comment lines. So I'm saying this is the syntax np dot array. Okay, so I'm giving an array of three numbers 1 comma 2 comma 3. That's your a, right? Then I can also say something called some instruction called a range. A range. What is a range? It says the syntax is start, stop, and what is the step, right? So I'm saying start from 0, end at 10, step size is of 2. Step size is of 2, right? So what would be the answer? See, between 0 to 10, the number should be in the screen is not visible. Is the screen visible? One second. I will unmute the participant. Is the screen visible? Someone put in the chat box, please. Shows plain. Oh my god. Is it from the main? I'm just. Is the PPT visible or only the this Google Colab is plain? You can. And I'm asking how long it's black. Last last 5 minutes. Okay, fine, fine. Okay, so from the, I think the coding part, I will share the screen again. Please excuse me. Is it visible now? Yeah, someone help me in the chat box. Is the screen visible now? Okay, okay, thank you. Thank you, thank you. Right. Okay, fine. These some instructions, right? I can quickly run through it, right? And you can say some instruction like linspace is there. Okay, what about the linspace? It says the start and stop and the number of points, right? Look at the instruction, look at the line. I'm saying np dot. Np dot means I'm saying that numpy dot linspace between 0 to 1. I am going to split into 5 points, right? 0 to 1 split into 5 points is the answer would be 0, 0 0.25, 0.5, 0.75, 1. Okay, and I can and see if the screen is something an issue, please put it in the WhatsApp group, right? I can see there also. Okay, and you can also create a matrix of zeros like 2 comma 3. It helps to create a 2 rows and 3 columns matrix. And you can also np dot once creates a 2 cross 2 matrix. Okay, now everything is ready and I'm going to run it. Already I have run, so I'm going to clear the output. I'm going to run again. You see, within a second, less than, it takes only 0 seconds, less than a second to run this thing, right? So array A is 1 comma 2 comma 3. The range of B is that is from 0 to 10, step of 2. The length is 0 to 1 with 5 points. Then 2 cross 3 0 matrix, 2 rows 3 columns, 2 cross 2 of 1 matrix. Okay, array, right? And I can also do operations like reshaping and combining, right? You can see here we are creating two arrays. Array 1, array that is np a range 1 comma 7. Okay, 1 comma 7 means 1 to 7. We are creating a numbers that is 1 to 6 is vector is generated. Then we are that array is reshaped into 2 cross 2 comma 3. Okay, the array you created is 1 2 3 4 5 6. Now it is reshaped into 2 rows and 3 columns. Okay, that is 1 2 3 is the first row, 4 5 6 is the second row. Then we can also stack it vertically or horizontally. Some instructions like vstack, hstack, concatenate. We can see the outputs given in the command line. If I run it, you can see it takes less than a second. It's all coming here. Okay. Then it also does the basic math operation, right? Now what I'm doing is I'm creating a variable x, which is having a np.array 1, 2, 3, 4, 5. That's an array. Now I can say print x dot sum. Okay. Then x dot mean. What is x? X is the array. Okay. So x dot mean is the mean of the content in the array. Then x dot standard deviation, x dot minimum, x dot maximum. I'm going to run it. Okay, it gives the sum value, mean value, standard deviation. Minimum value is 1, the maximum value is 5. These are some trivial, operations which are done. And you can see here these eigenvalues, right? You know, in electrical engineering or any control system or signal system, to test the system stability, we go for eigenvalues, right? We compute for any, 2 cross 2 or 3 cross 3 comfortably, right? But these are all done with faster, easier way uh, by the Python. Okay, you see here we have two arrays. Array A is 2 rows, 2 columns. First row is 1, 2. Second row is 3, 4. Array B is 5, 6, and second row is 7, 8. I can add those arrays. I can element-wise multiplication. I can do. Dot product I can do. Matrix multiplication is the dot product. Then I can take inverse of that matrix, right? Then I can find out the eigenvalues. Just I click it within less than a second. I get the output. It gives the eigenvalues and the eigenvectors. So that's what the computational. Okay, see, I have not installed anything. Everything running in the browser itself. That's the big point, right? A big advantage we can derive. And see, we can see these lines are the text line. These are the text line. These are the coding we are having, and we cannot in the comings. We can also see the plots also. So this we say as a notebook. It makes learning, developing things very easier. These are all offered by Colab at free of cost, right? But it's everything we need internet, right? Everything will be saved in your Google Drive. Then some random numbers you can generate. Okay. Now we move into pandas, right? You see, I'm having 3 students whose name is ABC. Their mark is 88, 78, 72, and 91. Okay. And if I say df dot describe, it will describe something. What is the count? How many students are there? What is the mean of those students? What is the standard deviation of this mark? What is the minimum value of this mark? What is the 25 percentage? How much percentage? 25 percentage of this variation, 50 percentage, and 75 percentage. What is the maximum mark? Okay. Then how many students are greater than 80? Greater than 80 is student A, which is 88 marks, student C, which is 91, right? In a simple code, this pandas help to, this is a matrix, right? In the table of content. In the Titanic example, we can still explore a bigger data than a small example. And this next we go for the plotting tools. See here, for plotting, we will be using this matplotlib.pyplot. In short, we are giving us, it is named as PLT. Now, wherever you see, it is plt.plot, plt.title. The meaning is it is matplotlib, matplotlib.pyplot is renamed as, we are imported as PLT. Okay. Now we see what is a x. X is a vector, row vector, 1, 2, 3, 4, 5. What is y? Y is I square. Y is I square. I square. That I, we have to take it from x. Okay. So how many values are there in x? 5 values are there. The first value is 1, second is 2, so 5 values. So if you are, that is the meaning is, what is y? For I is 1, it is 1 square, 2, it is 2 square, 3 is 3 square, 4 square, for 5, it is 5 square. We are going to plot it. So what we do, the construction is very simple, plot dot plt dot plot x comma y, we are going to say the marker. For the points, we are going to use a circle. For the line style, we are going to use a straight line. The color, we are going to use blue. And the label, we are going to give it as y is equal to x square, right? And we are giving the titles, those things, right? Now I'm going to run it. You can see the plot, the line plot is readily coming, right? It clearly gives x-axis. In y-axis is nothing but this. We give the name as y-axis label as square of x. Is a line plot example. Then the scatter plot, you can see some random numbers, right? Again, NP, numpy, right? Random numbers. Some 50 random numbers we are choosing for x, and 50 random numbers we are choosing for y, and we are using plot scatter. So this does the job x comma y. Random numbers in x and y are plotted, and the color going to give is green G, and the marker is x, and give the title label, and the plot is shown. So I can run it again if needed. Yeah, it's again a random. Okay, every time I run, a new random numbers are chosen. Okay, new random 50 data are plotted. Okay, then about the bar plot, you can see the subject. I'm taking 4 subjects, and the 4 subjects students have chosen obtained this mark. And for vertical bar plot, it's simple. It's PLT dot bar. What is PLT? PLT is that matplotlib is renamed as imported as PLT. PLT dot bar subject marks, and the color is going to be orange. And what about the title, label, X label, Y label, and the instruction plot is shown. Right? We get the bar plot. These are the visualization tools. Then we have the histogram. Histogram, histogram is how many times the value is happening. That's a histogram, right? Okay. So we are going to again generate random marks between 50 and 100. How many marks? 200 marks we are going to choose between 50 and 100. We are going to group it. So 50 and 100, okay, we can see 50 and 55, between 50 and 55, 25 marks are there. 55 and 60, 15, nearly 16 marks are there. And 95 to 100, around 28 marks are there. So totally 200 marks. Okay, this histogram. Then we can go for box plot. Run the code, we can see the box plot. Most research paper are nowadays coming with this box plot to plotting the content. Like the different type of plot, right? You can see the math, the mark is 80 for physics, is slightly less than 80 for chemistry, it is between 80 and 90, 85, I can say. Okay. Then next is the heat map, right? You'll understand the heat map. Yeah, this is the heat map. You see, a random number 5 cross 5 value is chosen, right? Okay. Right. And if the value is very close to 1, it is dark blue. If the value is very close to white, it's 0.1, less than 0.2, it is white. If it is in between 0.5, it is light blue. You can see the color is transforming from white to dark blue. This is called heat map. You can see 0.99, it's a very high value. So it is a dark blue. 0.09, it is white. 0.069 is white. We can see 0.35, light blue. Okay. So these sort of things will help to visualize better, right? See, I'm using a random number, right? 5 cross 5 random number, some random number of generated, I'm plotting it. Okay. But you have the data, we can visualize it. We can relate it based on their values. If you want some value to be shown. See, in airport, right? During COVID times or some sensing the body temperature, what they do? They really use the heat map. They will sense which part of the body is a bit warm, right? Someone is having fever. So immediately it will show under their throat, maybe in the chin, the temperature will be shown in red color, heat map. Other place will be in slide white. That's a heat map. Okay. Now we will move into uh, the demo example which we discussed in the slide, the iris flower. Okay. We have three sort of iris flowers we have. We are going to uh, classify. Among the 150 flowers, we are going to run and classify. See, it took only, see, first thing, I quickly run through these slides, run through the content, right? First step, see, I am using scikit-learn to import the data set, okay, and it is given the name load iris. Then I am model selection. I am importing train split cross validation score. Pipeline is import as pipeline. Then pre-processing, I'm using standard scalar. Then the model I'm using is logistic regression, which is the classification model. Then the metrics I'm using is the classification report. Okay, these are all readily available. No one need to write the logistic regression coding from the scratch. Okay, no one need to write the pipeline coding in the scratch. Okay, just you have to call the libraries. That's it. Our job becomes very easier. The first step would be the loading the data set. It's very simple. As we said, the data set will be having in the form of x comma y. X is the input, y is the corresponding output, right? What is the input in this case? For loading the iris flower, it's the feature. X is the feature. For each flower has its own feature, like the sepal length, sepal width, petal length, petal width. They are the features. 4 features we have. And what about the output? That's the label or the target, I can say. I can give the label in terms of numbers 0, 1, 2. 0 for setosa, 1 for versicolor, 2 for virginica. So by saying x comma y, load iris, return x underscore y underscore equal to true. That is in the load iris, if it is true, that the data set is loaded into x and y. Okay. The second step, in the first step itself, we are going to split into training and testing, right? So what I'm saying, the test size is 0.2. That is 20% is going to be testing. So the remaining goes for, that is the test is split is given as 20%. So 20% is going for testing, 80% is going for training. So this instruction, train, test, split, will do the job. Okay. So see, the one line code is enough to get the data, to split the data into train and test split. Then in the second step, we go for the pipeline. The pipeline, a pipeline is the scaling a logistic regression algorithm we are going to use, right? See, we just use the function logistic regression, and we are saying that maximum iteration is 1000. And the scale feature, we are going to use a standard scalar. The standard scalar, just nothing but the mean is 0, variance is 1. That is the condition we are fixing. This is enough to generate the pipeline. Next, we go for cross validation. That is, we are going for 5-fold cross validation. That is, we can see in the comment line, the split training data into 5 parts. 4 parts is used for training, and test is done for 1 part. And the scoring is the accuracy is the metric we are using. Then we are going to print the accuracy in terms of mean and standard deviation. Then the fourth step, we are going to fit it. Fit is nothing but, that is what I can say. We are using the standard scalar logistic regression to develop the model, right? Okay, that is the fit. What I'm doing, I am using X train and Y train. For X train, 80% of the data, the corresponding label we are getting, and I'm going to train for that. Okay, the model is ready. Once you run this fourth step, this green color all comment lines, right? So the actual code is only few lines. Okay, next we go for the prediction. Just pipe.predict that x underscore te. T is the test. We're going to predict, corresponding is y prediction. Okay, input flower is coming. Input flower feature is coming. One among the 4 features. The output prediction can be 0, 1, 1 or 0 or 1 or 2 based on the type of the iris flower. Then at last, I'm going to create a classification report based on my y test and y prediction. Right? Okay. So this is the code. The code may look, because the command line to self-explanatory. The coding is very simple. Okay, we are just importing the libraries. Then, as I said, the 4 steps are followed. I will delete the clear previous outputs, right? Now I will run the code. I don't have the output with us now, right? Okay. Yeah, you can see. Yeah, accuracy is 90% accuracy. 97% is accurate. Okay, that's a very good accuracy. The 150 flowers among the 80% I'm using for testing, training, 20% for training. So after training, if I see the 97%, it is having the precision is 97%. And maybe the one more example is the Titanic data set. Quickly, we'll run through this, right? You see here, the Titanic data set. You see here, the data set from the URL itself, we can derive, right? See, from the GitHub content, I am Titanic CSV file, I am deriving. And I'm just look at this, it's all self-explanatory. I will try to share this code with you in the WhatsApp group. We will be reviewing the first 5 rows, then we'll be checking the shape. As I said, it is having 891 rows and 12 columns. Then we have the basic info, right? What are the infos? Then we're going to describe. Okay. Then survival. See, here we are just doing exploratory data analysis, right? You're not going to identify whether the person is survived or passed, non-survival. Just we are going to see and understand the data. We are just visualizing the data. That is the purpose of this. Okay. I have run the code. See, it takes only less than a second to run. You see what is the count, what is the mean, what is the standard deviation. Is for the first 5 passengers. Okay. And at last, what is the survival? 549 people, unfortunately, they lost their life, and 342 people have survived among the 891. Actually, 2000 people traveled, right? This data set has only 891. Maybe that will only be available in public domain, maybe. And other things like from the data, what you have observed, maybe the passenger age, survival by gender. You can see 74% of the male have female have survived, 18%. The rest reason is they wouldn't identify their sex, whether it is male or female. That would be the reason. Okay, and 12 features they are using. Okay, this is regarding your this entire thing I have done using Google Colab, right? Okay, how to quickly I'll say, just you type Google Colab. You can go inside and you have to just sign in. That's all. Okay. Next is this is your Kaggle. This I want to share just a couple of minutes in this. Right. You can see kaggle.com and you can log in using your mail ID. Okay. Here you can see the big thing about the Kaggle is it has so many data sets are there. Okay. Based on departments, right? Computer science, education, classification, NLP. So many data sets are there. And so many models have been developed. So many benchmarks are there. And here you can start your coding. You can start your own coding. Yeah, as you have seen in your Google Colab file, new notebook. You can start your coding. Okay. You can code. You can write your code here. Then other than that, the important point here is they do keep so many competitions. right? Give me a second. Yes, yeah. This is worth knowing. See here, Kaggle keep conducting competitions. This is the Titanic disaster. How many? It's so very long. This is the first competition. Like 13,000 teams have been still this guys going, and this house prize competition. Nearly 4,000 people, 4,000 teams are formed. 16,000 means 4,000 teams are participating in this competition and other ladders competition. And you can see the prize money of some competitions, right? Like you can see here, Jigshaw Agile community. They say it's $1 lakh. 1,000 teams are there. You can click inside it. You can understand what is the overview of the competition, what is the data, what is the code, what is the model. You can write your own code. You can post it, and we can win the prize. Okay, and we have a very good discussion forum is there. Okay, people keep posting their own learning, and people will be answering their peers queries. And this is very important striking feature. Instead of searching content to learn, they themselves offer many hands-on learning courses, right? So this would be the starting point. Like you can see, you go to the learn, we can see some courses like these are the yeah, you can see Python. This course to learning Python, it takes only 5 hours. It's a beginning course, right? Very interactive course. We'll be working in Kaggle platform itself. It's very easy and learnable. It's very friendly to learn. Python course, intro to machine learning, pandas, intermediate machine learning, data visualization, intro to SQL, intro to deep learning. These courses will be really helpful to start with because it takes only hardly 2 to 3 hours. Maybe professors or faculties can help, can pass this information to the student, and they will, at the end of the course, the student will be getting a certificate from the Kaggle itself. Okay, these are all self-paced courses. So with the zero fees, so it's really a good thing to start with, right? Okay, so with this, I think I can stop the session. Yeah, any queries? Uh, I'm very happy to answer. Is the session okay? Any queries, any specific queries? Just the point here you want to take is you please explore the Kaggle and Colab, and it will be helpful maybe for the student community. Maybe the one who is doing research will be helpful. I started myself from EC background. This helped me to, I mean, in my research, it was very helpful. These two areas. Okay, then I think I can wind up the session. I want to thank my fellow coordinator, Dr. Dinagaran sir, for immediately saying that you can go ahead with the session, and my HOD, Dr. Mary Sugandratina ma'am, and our principal, and Dr. V. Gita madam, and ATAL FDP for giving this chance and meeting this diverse audience from various fields. Thank you very much. Someone is asking in chat which most widely used platform. See, widely used platform. If you take in academic side, this Kaggle, you can see thousands and teams are competing every session. I mean, every contest. Kaggle is good. Even Colab is good. And I forgot to say, they are offering their own GPU and TPU. Okay. Maybe for restricted 7 hours per week. Some data is of very, how I can say, a very large voluminous of data. In that case, you can go for this Kaggle or Colab. Okay. Right. Okay, right. Yeah. Thanks for listening. Have a good evening. Thank you.